Hello, most valued viewer, and welcome to my YouTube channel. I'm Daniel, and I'm a software developer and audio engineer. And this is hopefully the first of many developer logs for SynthVR. And I guess this is also an announcement that I am building SynthVR. What is SynthVR? SynthVR is a simulation of a Euro-rack modular synthesizer built for virtual reality. So this is something that's come out of kind of a scratch your own back scenario. So I really like electronic music. I really like synthesizers. I really like modular synthesizers, but I don't feel like I can afford one. I don't feel like I have the space at home for a modular synthesizer. So what can you do? You can simulate it, right? And there are some cool software out there already to simulate modular synthesizers. Reactor from Native Instruments is one approach. Also VCV Rack, which is really cool and like open source, and I really like that project. But these are modular simulations made for the screen. And what I'm really yearning for is the physical tactility of the modular synthesizer. Being able to take things and move them around, pull connections, wires, twist knobs, turn faders, or turn knobs and move faders, or whatever, and do that and feel like I'm in a space, like with a modular synthesizer, like Junkie XL and his wall of fucking synthesizers. I want to feel like I'm doing that without spending $10,000 on a piece of gear and having to figure out where to put it. So this is what SynthVR is about, and it's come out of a prototype that I built. That's 3 years ago now. I had one summer. I had a lot of time. And I thought, wouldn't it be cool if you could actually do modular synthesis in a game engine like Unity? And how would you go about it if you wanted actual modular signal flow and being able to like patch things together? So I built this prototype, and it worked. And there was like some things there's some problems and some things you have to figure out how to improve. But all in all, it actually worked quite well. So I'll show you screen recording from back then. Let me just make that full screen here. So this is the screen recording. This is in Unity, as you can see. And this was built initially for the HTC Vive, which was the headset that I had at the time. And what you're seeing here is just I'm like spawning some different modules. So in this prototype, the idea was you'd actually set up like your speakers first, and then you'd end up like patching your audio cables to the speakers. So I'm just going to see if I can skip ahead here. So here are the speakers set up, and here is a clock module. And as you can see, this initial version, like it's a very kind of it's called skeuomorphic interface design, like just trying to kind of emulate real life as best as possible. As you can see here, I'm just hooking up the clock to some speakers, and we can hear the kind of impulses coming out of the clock. And here I'm trying to figure out where I put the module that I wanted. So this is an envelope generator that fits right in there, and also spawning an oscillator. So the oscillator, so movement at that time was a little bit buggy, so didn't really fit in there, as you can see. So, but you could put it down there, and that worked fine. And so now we're just hooking up the oscillator to the speaker, as you can see. The knob twisting interaction here was a little bit weird because you twist it kind of like a wheel. Now we're patching the clock into the envelope generator and feeding that into the oscillator frequency modulation input. And so You see, that works, and we're now like at signal rate or at audio rate, we're modulating the frequency of the oscillator, and that goes to the main output or one of the speakers, which is actually spatialized in this version. As you can see, it was pretty quick actually to get a bit of a rhythm up and running, even though I actually never built a sequencing element. And what I want to kind of just highlight about this prototype is because it worked fine, but obviously like a lot of shortcuts were made to make it work. I got some ideas not quite right in terms of how to solve it the best, how to solve the kind of the modular signal chain problems. But I just want to show you how much fun I ended up having with this prototype. So just like skipping forward a little bit, see around the point here, using like a frequency quantizer. So that's like quantizing what would be like control voltage into like musical scales. And you can see the head bobbing, and you can see like we're having a good time here, right? Starting to dance around a little bit and feel like that I'm actually accomplishing something. Like I feel like I'm making some actual synthesizer music in VR here. And so this is the experience that I really want to try and just really try and nail that experience of being there in the space, moving stuff around, using your body, even though you're kind of programming, right? It's kind of programming a patch, and in that sense, it's pretty lenient towards VR, because an issue with VR is that there's some latency. So I've tried, for example, like drumming simulations in VR, and it's weird. First of all, because you don't have the tactility of like hitting something, but then other than that, the update rates of the headsets are like between like 50 and 100 frames per second. So that's actually not that often. That actually makes it quite hard to play in time. And also there's a little bit of latency. So when you see yourself doing something on the computer and in VR, and you hear yourself, like you hear the reaction afterwards. And usually it's not a problem, like in a general kind of gaming experience. But when you're trying to play music, that latency is just really problematic. You just really need low latency. Or in this case, if you're into modular synthesizers, it's not as much of a problem because you're not playing as much directly as you're kind of interfacing with a big synthesizer program. You're patching, you're programming your procedural piece of music, procedural kind of synthesis patch. And so that's why I think for me this prototype worked. I really liked it, and I really kind of had high hopes that I could return to this and finish it and like release it somehow so that other people could enjoy this with me. I never got to that point. Ended up getting a job, software developer, actually working more with VR, but not really music related. I'm still working as a software developer in machine learning specific kind of tasks. But now I'm in a space 3 years later where I actually have the time and the resources, and I feel like the experience that I need to accomplish building this project. So that's why I'm here now. I'm making it public, and I want to kind of share the thoughts going into this project coming along. Also because it would be, I think, really cool to get some inputs along the way, get some feedback from outside, and like figure out what works and what doesn't work. So, for example, one of the things that I thought was going to work was this kind of, because in VR you don't have kind of the same, you have quite the same resolution. So you're twisting a knob, right? But in VR you're with this like big chunky controller. That's the Vive controller, but you could even be like, this is an Oculus touch controller, and you can like do something and you can, you know, move it around or whatever, but you don't have the same resolution in terms of like getting just the right setting. So what I thought I could do was you could like select the thing, select the controller, and then you could like wheel it around like it was like a valve or a wheel in a car. And that just to me it worked because I knew this is how you can do it. And you know, the further out you go, the more kind of resolution you get on the parameter. But people tried it and they were like, it doesn't work. They like twisted it like they expected a knob to be twisted, and of course that's the expectation. You see a knob or a dial and you're thinking, yep, this is how I twist a dial. I don't twist it by like wheeling it around like that. Then I'd expect to see a wheel. So the goal here is to make a Eurorack modular simulation that is, first of all, it's fully modular, and it is fun to play with. It is accessible, so that it's built in such a way that you don't have to be like, you don't have to worry too much about like these kind of problems where how do I get like this particular setting, how do I get that working? Don't want you to worry as much about that. And want you to more just focus on the fun and the feeling of creativity of playing modular synth, programming something that you're coming up with on the spot. You're patching connections, you're making connections between modules, and you're doing random things to see what they would do. Like now that I have this patch that's so complex that I couldn't possibly fathom how the signal is flowing through it anymore, what happens if I twist this dial? And I want you to experience that kind of fun in the physical space. I want you to like move around. I want you to feel like you're sat in like a big like space station with, you know, like Junkie XL or Dead Mouse. You know, I want you to be able to experience that, like being in front of this enormous machine and being able to play it and explore what happens when you screw with signal paths and you screw with sound generating modules. I want you to be able to experience that in VR. And I want it to be mobile VR. So this is another kind of constraint. This came up after this prototype because this prototype is running on a Windows gaming PC with the Vive headset. But that is problematic if you don't have a big gaming rig. And actually, if you're into music and synthesizers, it's actually quite likely that you'll have a MacBook. Or like, it's very common, I guess, in the music industry and for creatives in general. Like, have a lot of people have Mac OS. They don't have Windows gaming PCs. But what you can get is an Oculus Quest. So an Oculus Quest is this like new mobile VR headset that Oculus has developed, sponsored by Facebook. And when I first tried this, I was working in kind of a VR development shop, and I was so breathtaken by how high of fidelity you could actually get on a headset that is cordless and can track in however big of a space you want. And it tracks really well. It looks pretty good. You know, it doesn't look like a AAA, like super duper high fidelity game, but you can get some decent graphics out of it. And it doesn't cost a lot. Like you don't need to buy like a $2,000 gaming PC and spend another $1,000 on a headset. I think these are like $500 each. So that's like what the price of a couple of modular like modules. So if you didn't have VR, you know, I was already into VR, but if you didn't have VR and you wanted to get into it, then at least you could pick up something like a Quest for, you know, $500, and you'd be able to get into it, hopefully. So that's the dream, and this is what I'm working on developing. And so I want to try and share a little bit of that kind of experience with everyone here, everyone who's interested to see how it goes. I feel like I have the proof of concept. I know it works. I know it's fun. And now I want to make it happen for real. And one of the things, there's like a couple of things that had to be solved in order to make that work. So one of the things that I had a big issue with was infinite chains. So say you take a module and you, let's say you take a module and then you feed it into something that splits it into two like signals, right? And then you just feed one of the signals back into the module and the other signal goes in the speaker. So you can do that in an electrical system. And I'm not quite sure what happens at the physical level, but like at the creative level, it's like a bit of chaos ensues because you're feeding the output of the thing back into its input. And so you're creating this kind of cycle, you're creating like this kind of infinite loop where signals are like flowing back and affecting the signals and flowing back. And it kind of creates some really interesting effects and it's a lot of fun to do. But in a computer, and the way that I ended up doing it in the prototype, so the prototype would like take each module, would like call back to any connected modules and like say, so like at the end, the module would be like, I need to process some audio. Okay, who's connected to me? Like have them process their audio, and who's connected to those, have them process their audio, etc. The problem is that if you do it that way, and you get a cycle in this kind of signal graph, it breaks. It breaks because you can't ever reach the end. You can't ever compute the end of the signal. So I was thinking, how do I get around that? And actually, kind of just figuring out how I would actually do that ended up being the trigger for going back and doing this like for real. And the solution ended up being introduce a delay. So you can make an infinite connection, but it won't be computed immediately. So the infinite connection in the SynthVR kind of solution, the infinite connection ends up being scheduled forward. So you compute all of the connections except for the cyclic ones. The cyclic ones you process and then you'll put them in memory and then you take them back in the next kind of processing cycle. And that actually makes it so that all of the signal processors in your modular setup can be formulated as, it's called a directed acyclic graph. They can be formulated as a graph where you have inputs and they're flowing through different nodes and at some point ending up at an output. And doing this, you can guarantee that there won't be any cycles in the graph. And this is important in order to make it computable in the sense that I wanted to. So that's one of the solutions that's kind of triggered my excitement about SynthVR again. So it's this way of introducing a delay to make an actual cyclic graph, make it appear acyclic because of the delay between the processing steps. And I actually ended up figuring out that this is how other modular simulations have gone about solving this problem as well. So that's what I've been doing. I've been watching a lot of Colin Bender's. You can see that, Colin Bender's, so cool. Watching a lot of modular live performances while I've been working on it. And also Olan, a very cool modular techno. So all good stuff. And what I've been doing up until this point is I've built basically the audio engine. So the audio engine runs on JUCE. If anyone's interested, this is, let's see if I can make this appear. Here's JUCE, or the producer. And JUCE is like a toolkit to develop audio apps. So you can use JUCE if you want to develop a VST plugin, or if you want to develop some sort of audio, some sort of app where audio is important. But you can also use JUCE to develop audio libraries, and that's what I've done here. So JUCE integrates into Unity as an audio library, and you can build it for PC or Mac, and you can also build the library for Android. So there's like across the board platform support for the JUCE library. So the Oculus Quest runs on Android, and so I am developing an audio library that can run on Android and also on Mac, on PC, whatever. So not too limited, but still like focusing on it should work on mobile VR. And so with JUCE, I have a bunch of tools that I can use to implement like audio processing stuff that needs to be native, stuff that needs to happen quickly. So I started out by figuring out how you could build like a processing graph. So recurrent processor graph. So this is a class that wraps basically like a JUCE class, which is like the an audio processor graph. So that's just a way that you can take a bunch of like audio processing elements and coordinate them into a graph and then process the whole graph in an efficient manner. And then I've implemented stuff like some test processors so far. So here's one that uses like the JUCE DSP stuff to so like DSP oscillator, DSP gain, just to do a really simple kind of test processor that'll run an oscillator and create an output. And that runs in Unity. So that's implemented in Unity. It's a plugin I have for Mac OS and Android. And then on the VR side, I started out by building the like base components that I would need for representing it visually, and also the interactions that you could use to actually interface with all this stuff. And so I ended up with a bit of a dogma. So the dogma is that as far as it's possible, dimensions follow the Eurorack convention. So the casings for all these different modules that are going to be built are going to follow the Eurorack dimensions, except for one thing, which is everything is twice as big. And this is because in VR you have plenty of space. Like typically like a modular rig would be like something like this, something that you'd have at home, right? But in VR you have the whole wall if you want to. We have plenty of space. We have like 360 freedom as well. We can place the modules anywhere. So that's not as much of an issue. But what is an issue is this kind of resolution problem where you want to be able to easily grab things and you want to be able to easily control them. So everything is twice as big, and it looks a little bit enormous if you're used to Eurorack, but it'll look familiar because everything will follow the kind of conventions of Eurorack, just bigger, and that's fine because you have more space anyway. So here's like a demo case with some of the different modules are on it. No, not modules, sorry, components. So like there's some dials that you can turn. There's faders, so like regular faders and backlit faders. There's buttons that you can press, buttons that can be lit up. And this actually all came out of, I'll show you the initial designs. So the initial designs came out of here. So like I just started in 2D, and I said, well, maybe I can open it properly here. I just said, well, how would this look? How would this look in a kind of minimal art style that's going to be mobile friendly? How could these things look? So this is how like input outputs could look, and there would be like just glowing circles with like a hole in the middle, and connections would be these kind of white lines that you draw in between. They'd all be like glowing. How would knobs look? Well, they would look something like this. They'd have these kind of accent colors, encoders, how would they look, etc. Switches, how would they look. And I just try to go for a very simple art style. And this can, of course, this can be changed out later. I'll probably need some help from someone who's more arty than I am. Text displays, this is the wrong font, but like, and like pixel displays as well. And so I ended up modeling all that stuff. Here's like an idea of like how could like a sequencing module be set up with these specific elements. So started in 2D and trying to work out like the base components of the modules, and then I actually I just modeled those, modeled them in Modo, and exported them to FBX models. So like let's see, knobs. Let's see, different. You can see them down here, right? Different dials and different sizes, and using a bit of a trick to make the rendering nicer, or make the rendering easier, to have to texture them in a certain way. So I ended up developing the models, and next step was like getting them in and getting them to appear on a module and figuring out how it goes together with the code. And you can see that, here it is. Here's some of the modules. You can see they're glowing. They like glow in the direction of the camera, which is like why it looks a little bit weird. I can like maybe I can move the camera up here so it's looking at it. And it's like, okay, that's fine. So that's like how some of this stuff would look. Oh, sorry. And then I've gone on to figure out how to like develop the interactions. So how do you calculate when you grab something with your controller and you start twisting your controller? How do you calculate how that translates into like a knob being rotated, a dial being rotated? So develop that. I've made buttons, dials, faders, I guess, and then being able to like take the whole modular case and pick it up. So I've been working on the final version of this for about a month, and today I kind of reached a bit of a milestone, because today the audio engine is running the test oscillator. It's running the test oscillator on the Oculus Quest, and you are able to use all the VR components to interact with it. And it's also running in this kind of a graph, this kind of a processing graph. So the audio engine has met the VR interaction component, which is really exciting. And I hoped that would go well, and luckily it's kind of come together okay. And like that's a really core kind of thing that needed to happen. And now it's like starting to extend that and figuring out like all the different ways that VR and the audio engine is going to interact, and also all of the components that you could put together and the modules you could make, and the audio processors that you could make, like how to go about making a really nice, cool oscillator, a nice envelope generator, something that's fun to use. So that's where it is now. I'm gonna do a demo. All right, so here we are. I'm just casting it to my phone right now. So I'm in my library. I'll just go into SynthVR Unity. And here's one of the modules. I can pick it up and I can move it around, look at it from some different angles. And these controls don't do anything. This one does. So let me just quickly go through these. So we have, let's see here, we have the dials, large dials. There's a bit of like outlining logic to that. So whenever you're kind of hovering something, then it'll outline. If you're hovering the whole case, you can kind of pick up the case and move it around. And obviously you can take the knobs and you can twist them, like your controller is being hidden while you do that. And I think you can twist two at once. Yeah, you can. So that's kind of cool. And I still have the wheel logic, so if you like pick it up and you go further out, you can, well, that's hard to see, but I'm kind of doing a wheel around it like this. Here's some connectors. These aren't implemented yet, but you'd be able to like pick it up and then drag a connection to over here, for example. some LEDs that'll light up in different ways. Then we have like smaller knobs. We also have a fader and another fader, like a backlit fader. And then buttons. There's a bug here about how they're being highlighted, but that's where we are for now. There's like this fake glow effect that's put on there. Same goes for this one. It looks okay most of the time, but sometimes it looks a little bit weird. So, but like, you want it to be like you're pressing the buttons and they're like lighting up like that. And also like you want the LEDs, they look pretty nice. So the way they're like lighting up. And it's actually just like a sprite, but it's made so it kind of faces you all the time. So even if you're down here, it kind of looks like volumetric light, but it isn't. It's just a flat kind of a sprite that's being shown. And there's also like an issue about that. Like if you were to see it from another angle, you can kind of see that they're rendering on top of everything else. So some improvements to make there for sure. Here's an actual sound giving module, just using the test oscillator, and the inputs aren't implemented yet, but this would be a frequency modulation input. You'd be able to control the volume here. And here's the volume of the actual oscillator. So there it is, I can control the volume. This is just to see that like VR and sound is interfacing, it's working. So that's where it is right now, Some interactions are ready to be used. There's actual connection between VR and the audio engine. So I think that is really exciting. And you can see here's just like a test stage. I'm in space. And there's all the spotlight on me. So like I'm kind of envisioning that you'll have these kind of stages. You'll be on a stage and you'd be able to also hook up like sound, you'd be able to hook up sound into lights and stuff like that. So kind of like DMX control, but not really, like DMX control at like the control voltage level. So you'd have lights that could be triggered by things in your modular rack. And so I think you could really like start using the affordances that being digital and being VR gives you to make the modular experience even cooler, So, but anyway, this is where it is. There's a connection and it works. So I'm very happy with that. It might be hard to hear actually in the VR headset, but yeah, that's it. So to wrap up, I don't know if this has been very rambly or if this has been okay. I'm certainly feeling animated talking about it because it's so exciting to me. Some good progress has been made. This is the initial kind of announcement and a bit of like talking about background of the project and what I'm trying to do and what's been done. Going forward, I'm thinking that this will be a little more concrete, getting into some code and getting into some like different technical things. And I hope that if you're watching this and you think this interesting, or you have some ideas or some feedback, that you'd share it with me. Because getting kind of outside world in on this is really the goal of these developer logs, and is getting people involved and getting people interested in what's going on, getting that feedback so that I can improve things and I can fix things that aren't the way that people would expect it to be. So with that, I'd like to say thank you for watching, and I hope I'll see you around on the internet at some other time.